Hello everyone, and welcome to this presentation about Virtual Labs 2017. This presentation will be split into different sessions. My name is Tiberiu Kovac and I'm a Microsoft Regional Director, and with me I have David Rodriguez, who is an Azure MVP. We are both working for Intelequia, which is a gold partner for cloud platforms and application development. So, our agenda for the first session, we are going to talk about why Virtual Labs, why it is important. Then we are going to look at the architecture and how exactly it looks like today, and then what different options for deployment we have available for us. The second session, it's a session about cost estimation, and we are going to look at how exactly can we use the tool that we put together for this particular purpose, and then how autoscaling can help us actually drive the cost for the solution even more down. So the first question, why Virtual Labs? First of all, we have a lot of users, or every university, and not only universities, but generally speaking, all companies have a lot of users that they need to use some applications. And we want to enable those users and at the same time to make sure that they only get access to the applications that they need. So we need a way to actually protect those assets. And when we work with Virtual Labs, we have offered different kind of options. We can either use a session-based desktop via the RDS, or we can create remote applications via RDS. And at the end, we can use as well personal or pooled virtual desktop via virtual desktop infrastructure. There are different solutions that might meet your requirement. The most common one is the on-premises solution, and most of you might already have something similar. We can have two different kind of solutions. One is the session-based computing. The session-based computing is based on the remote desktop and remote application. It's a very cost-effective and a very easy to manage solution. Another solution is to use virtual desktop infrastructure. And with the virtual desktop infrastructure, you'll get access to a pooled or a personal virtual desktop that they will run a Windows client operating system that offers you high performance and application compatibility. The second option, it's actually a cloud-based option. And again, we have the two different solutions. We have a session-based one, which is computing in the cloud. We have a remote desktop session host, and that would be deployed in the cloud. We are using those infrastructure already available there. And it is actually customizable with minimum capital expenditure, or we can go all in and we can use client desktop in the cloud. We can use Windows desktops in Azure, where we are creating a true VDI solution without a very large CapEx. So we need to see how do we choose the right architecture. And every time, it's based on what exactly are requirements for your application. So we are going to assess those from good, better, to better, and best. So first of all, we are going to look at personalization, then at application compatibility, how easy it is to manage that, and how cost-effective every solution it is. So if we take the first one, the personalization, Session RDS or the pooled VMs VDI are actually quite good, but the best one would be actually to use the personal VMs with the VDI. Now, when we look at application compatibility, again, the pooled VMs and the personal VMs will give you the best solution. The ease of management you get with the session, when you use an RDS, the pooled VMs and the personal VMs would be a little bit harder to manage. While when we look at the cost effectiveness, again, the session RDS are the most cost effective, but the pooled VMs and personal VMs give you a little bit more cost than normal. So we are going to have a demo about how we did the deployment for the University of Comillas in Madrid, and hopefully that will be instructional for you.
Let's start with a demo of the Virtual Lab deployment. So here is where I'm accessing the Virtual Lab web portal when I introduce my corporate credentials. And with that, I will see that we a set of icons and shortcuts that will open remote apps. So that will be the first type of session collection. But also we can access the two session desktops as well as VDI, so personal desktops. So let's start by something easy, like for example, opening the calculator. So to open the calculator, yes, I need to go to the calculator icon. So we'll notice that a new remote app is being opened. So this app will be executed on the server and will be streamed directly to my to my local desktop. So one singular thing is that we'll see that the icon that is overlaid with the remote app icon, indicating that it's a remote app application. So of course it works like if it were running locally. Let's try now with a more interesting application. Let's start, for example, Visual Studio. With Visual Studio, we can have the full UI that a developer can use just to build new applications and programs. So, and of course, with their favorite language. So I have already created here just a console application that has just a simple hello world. If I run this example, one interesting thing is that, as we can see, the new process that I am debugging is running remotely, but it's also open and redirected to my desktop. So if I continue debugging this, and we see that, of course, the redirection is done. So let's stop this one. Let's try now with a more interesting application, one that uses the power of the N series and the GPU on the server side. So one of that is the Unity. Unity is the application for building games and 3D applications. So I have already started with one here that will be interesting. So the application is the model is just a application with a human body. So and here we can see that we can rotate and whatever we want with the model. The interesting thing here is that we can see the power of starting to see the power of the GPU, because it's not only the auto model is composed by all the internals with each. For example, let me do something like, for example, selecting the skeleton, and this will be this part, and I can just move out from the internal body, so I can starting to see all the elements of the model. For example, I can the hands. For example, let's try with the veins. That will be this one. Okay, so we can start to see all the components. So for example, final one will be this one. Okay, and then start applying materials, textures to each of part of the component of the model. So we there's a lot of opportunity for learning here. So of course, remember that this is rendered on the server and being streamed directly to our local desktop. So, but let's try with another one that it will be probably more interesting. Will be showing more power of the GPU here. One of the applications that I love to see running here is just Google Earth. So Google Earth opening in the OpenGL version. Here we can see how smooth is the runs. So remember that everything is running on the server on Azure, and it's being streamed directly to my desktop. So let's try, for example, from where I'm just doing this webcast, Santa Cruz de Tenerife. So we can see some of the power of the GPU. So if we can zoom here, zoom. So there's a moment now that this is a new feature on Google Earth that start to show the buildings all in 3D. Okay, so here we can see, for example, and we can go closer and closer, and so for example this way. So remember that this is running on the server on Azure, and again being streamed directly to my desktop. Okay, so what is pretty pretty interesting to see how the speed and the smoothness of the rendering is done with all the parameters. So another one will be, for example, if we go to here to the Eiffel Tower. Let's try with this example. I'm traveling just now to Paris. So okay, here it is. Okay, so the same thing. So all the buildings in 3D. So you have to think the power you need on the server, plus also to render this locally with so smoothness. Okay, good. So we have seen some examples of remote apps. One with simple ones like a calculator or the Power of Visual Studio that allows to also including to debug new processes and being redirected here to my desktop, to my local desktop. And we started to see the power of the GPU for virtualization and for the virtual labs. So let's try now with the other two flavors. One is the normal session desktop collections, and finally the personal desktop. Let's start with the first one, session desktops. So just by clicking on here, so what will be open is just a session desktop that has been where I cannot install. I can just use the applications that the administrator has given to me. So again, because of the course that I'm following, because all the reasons, so I can just open and use these the applications. So for example, I can just use an open Word. So for example, to create my resume, okay, and just whatever I want to do. Okay, or for example, if I'm just for example creating a PowerPoint slides, I can just use it just from here. Remember that we can do this from different clients like Mac or iOS or Android. So for example, tablets from Android, you can do it as well. So of course, every application that you want to install here will be available for the users. Of course, they can, if you want to allow, you can also include, you can go and open internet and do whatever you want. So this is the the session desktop collection. So there's a final one that is the personal. So remember, the difference between desktop collections and personal desktop collections is that in this collection, all the applications has been pre-installed. So in personal desktop collections, you allow and you give the VM to the user, so he can install whatever he wants. So it's like being an administrator of that VM. So let's start, for example, this personal desktop session. Of course, being administrator of this VM. So now that I have logged in, I can have here this is my personal, totally personal server. So I can here install whatever I want. So I can manage practically, as we can see here, I can have server manager, because I can admin and install whatever I want here. So for that, I have in order to also to show the power of the NVIDIA, I have installed here two demos. One is here the pendulum. Here shows the power of the NVIDIA running on the server. And remember that this is a remote desktop session, and this is being rendered as you can see here in real time. So in fact, I can rotate, I can move around the scene that is being in real time being rendered on the server. So in fact, for example, if I run here the CMD, go to program files and program files, and then NVIDIA, and then NVIDIA CMD. Yeah, not this one. Okay, give me a second. This is the and then NVIDIA. Okay. Okay, so we can see that this lists the MVs that are running, the processors that are running on the server, and we can see here this currently running at 90% of consuming that Tesla 60C, the Tesla M60 card. Okay, so let's try with another interesting demo that we have here. Another one is a new down. I love this one. So this takes some seconds to load all the resources, all the materials, but believe me, that is quite amazing. Okay, here is loading. I'm going just to jump this intro part, just going directly to the demo. So remember that this again is rendered on Azure, and it's being I'm remote desktop, and this is like an scene with all the lights, all the effects, all rendered and being rated. I mean, stream directly to my desktop here, so far away. So in fact, for example, to show that, I'm going just to open here some controls. I'm going just to set auto camera on and start playing with some controls here. So one of them is, for example, to change the day mode from day to the night. So as you can see here, this is real-time rendering. And another interesting one will be, for example, also to change while giving more light, or I love this one that is change the depth of field. So if you see the background, it's more needed, and if I change this, is more blurry. Okay, just to show that thing. So this one also shows another interesting one. I love this one, the hair. How is show more exposure. So well, again, this is being rendered in real time on Azure and streamed directly via remote desktop to my surface. This is pretty amazing. Again, we can see that here how it's being consumed, the Tesla, and can give us an idea of the things that we can do with these types of VMs. Okay, finally to end, I would like also to remember that Remote FX now supports the ink and pen tools. So of course I can just with my pen, with my surface, I can just start drawing or whatever directly, also via remote desktop. Okay, that is now support. So what this opens up again a lot of new fields or a lot of new possibilities with this type of deployment in virtual labs.
So as you could see in the demo, it was very easy for us to start different kind of services and look at them, how they work. So what exactly makes up the solution, how it is built? So there are different components that we used in that solution. First of all, we have a session host, the RD session host. That is actually the user desktops and the application are executed in those host servers. Then we have a connection brokers. That's the one responsible to distribute the connections to different session host servers. We have a web access that's the one that we saw the very first screen when we logged in, and then get the list of all the applications available. So it gives us a logon and selection of either desktops and the applications that we want to use. And then we had the gateway that routes specific traffic to the internet or to the tenant network. So depending on how you configure your network, you might or might not need a gateway. And then we have a license server that will track the usage of the system. So there are different concepts, and let me walk you through the concepts that are normally used when we talk about remote desktop services. First of all, we have the notion of a collection. A collection is either a farm or a set of remote desktop server hosts that are hosting our VMs. Users are assigned to one or more of those collections. Then we have two types of collections. We have a pooled RDSH collection, where the users are connecting actually to the next available machine each time they log on. They might or might not actually get the same machine when they are working. And then you have the personal RDSH collection when a user is assigned a specific VM, and then it will always connect to that VM. The reason you might want to do that is especially when you want to give the user the admin rights to that particular server, when they might want to install their own application, and you might want to be sure that they are not switched between different machines. And then last but not least, we have the user profile disk. Because the machines are remote from the user, you want to have the user profile information as close to the machines as possible. So for each RDS session that you get, the built-in user profile is actually pulled and it's saved into a server as close to the machine as possible. So this is actually stored in a file share and mounted to the appropriate pulled VM before the logon even happens. So one of the things that you need to keep in mind is that the user profile disk cannot span multiple collections. Now, when we are looking at remote desktop services, there are a lot of limitations in Windows Server 2012 and 2012 R2. So let's look at those limitations. First and foremost, it was a cost-associated one. When you wanted a high availability connection broker, it required actually the SQL Server to be deployed in at least 2 virtual machines. And if you had an Azure deployment, to have at least 2 Azure virtual machines. It required as well 2 Active Directory servers for two Active Directory virtual machines in order to host the Active Directory. When we talk about the scale, then we have different limitations, like the server manager GUI do not scale past 500 users. And the connection broker, it's very slow during logon storms. So every morning when a lot of people trying to log in, you would see that the connection broker will actually be quite slow, and it will take a lot of time for user to log in, which normally creates frustrations. The reliability as well had limitations. There was no available file server cluster for user profiles. And when we talked about compatibility, then we had no ability to host applications that require graphics hardware acceleration in RDS and in Azure. And we had no support for personal desktops either. Now, with the upcoming of Windows Server 2016, we got a lot of improvements. So when we look at the cost, now the connection broker has support for Azure SQL database. So we don't need the 2 machines anymore. We can just use the built-in database with all the management tools that comes with it. When you look at Active Directory, we can now use Azure AD domains. So we don't need the 2 virtual machines either for this. Now, when we talk about scale, we have the server manager GUI has support for over 10,000 users, which means a lot, especially when you have a big university or when you have a big organization. With auto-scaling support, now we can actually create several machines that are playing the role of connection broker, and then we can handle logon storms without too much frustration. The reliability of the system now it's improved because we can use the scale-out file server cluster with storage spaces direct for user profile disks. And when we talk about the compatibility, we can use N-series virtual machines to allow our application to use hardware acceleration, graphic hardware acceleration in Azure directly. Plus that we can use personal desktops that in Azure with the new improvements. So if we look at the innovations in Windows Server 2016, we got the increased performance, not only in the graphic, but as well in the kind of machines we can use. We enhanced the scale, the connection broker and the shared SQL connection or the Azure SQL support, plus the support for Azure Active Directory application proxy support. And it is optimized for the cloud. It's more efficient and more secure architecture than ever before. Other improvements, we have support for generation 2 virtual machines. The end user experience improved. We have support for pen. We have support for window client desktop user interface improvement. We have actually Zoom functionality straight into the Microsoft Service Terminal service, support for personal desktops, support for multi-point services that now it's part as a new role in Windows Server 2016. The Hyper-V graphics virtualization has evolved over time. It started with Windows Server 28 R2 when we got remote FX with virtual GPUs. We have Hyper-V integration with support for DX9. Then in the Windows Server 2012, we added support for remote FX virtual GPUs with support for DirectX 11. And when we connect to a VM, we get support for VP GPU, for virtual GPU, and we get management of the GPU. We have support in the next version. We got support for DX 11.1. We have support for higher video memory and resolutions up to 2560 times 1600 with improvements as well for the scale. Last but not least, Windows Server 2016 added a lot of support for GPU in form of OpenGL and OpenCL. We have 1 GB dedicated virtual RAM. We have support for resolutions up to 4K, and we have support for server virtual machines and improved performance. And last but not least, we get support for discrete device assignment with full API support and native GPU driver support and maximum performance. Now, if we look at the evolution, we get to see that with the current remote FX, we get a very rich user experience. We have support for remote FX over 1, giving us the network condition or detecting network condition in order to give us the best experience. We have native support for GPU, both physical and software. Support for USB redirection, so I can connect a USB dongle into my own client machine, and then I'll get it accessible directly in my remote session. And you have seamless experience in form of multi-touch and pen support, and even start menu screen integration into your application. Now, Azure supports N series, which actually is GPU-based virtual machines. And there are two kind of instances that we have available. One kind of instance is visualization. That's very useful when you want to do rendering and you have to do a lot of graphic intensive applications. And the other one is compute. And the compute is actually when you have to use the GPU for a lot of computations, especially big data and number crunching and such. For the purpose of this, of the virtual labs, actually we are using only visualization, because what we want to offer our users, it's a good graphical experience with existing applications. Now, when we are looking at personal session desktops, that's something that is new into Windows Server 2016, meaning that you can actually connect a user to a specific instance of a virtual machine and make sure that the user gets the same instance every single time, giving them the option to install their own application. That will enable them as well, to use applications that require admin access, and also improve the desktop experience feature. So instead of having like the standard desktop, they can have their own choices and they can set it up the way they want. But just to keep in mind, this is a server-based personal desktop, meaning that you are going to run a session of your your applications or of your operating system inside the Windows Server 2016. Now, when we look at remote desktop clients, we can actually use them to access Windows from anywhere. And there are a plethora of platforms that are supported for that. You can have the remote desktop client for Windows, or you can use it from Android. You can use it from iOS or even from macOS. That makes sure that your data is kept safe, because this is a session-based desktop and remote applications that you're going to use, and the communication is encrypted all the time. And it offers you a great Windows experience because it's actually optimized for different form factors and for different kind of connections that you might have to your server. Remote desktop protocol has suffered a lot of changes from Windows 7 Service Pack 1 and to what we can see today. We started first with remote FX bitmap remoting, then we had support for USB redirection. In RDP8, we got support for adaptive graphics and even support for low bandwidth. So even though you have a low bandwidth, we don't have to send a lot of graphic information, making the experience quite good. Then we got support for remote FX progressive using the Calista codec. And last but not least, we had support for multi-touch and video optimization with remoting using the H.264 codec. In RDP 8.1, we got a better support for H.264. We have as well support for low-powered devices such as Windows RT. And then in the latest version of the RDP protocol, we got the 444 codec from H.264 specification and support for pen. So you can use your Surface or other devices that have support for pen together with the remote desktop. Now, one of the things that were added in the latest version, that Windows Server 2016, it's High Availability Connection Broker. Now, High Availability Connection Broker can either use a SQL Server cluster or it can use Azure SQL DB. And it improved the connection handling performance by allowing you to have over 10,000 concurrent connections. And even when you have log-on storm situations, you can use auto-scale that would actually allow the system to work seamlessly for all the users involved. We have another addition, which is actually high-performance storage at a fraction of the cost. We are using storage spaces replica that will create affordable business continuity and DR among different data centers, and that's something that is built into Azure. We have quality of services for storage, so we won't have problem with noisy neighborhood that will impact the workload, by using storage quality of services. And then we have storage spaces direct. They are using standard servers with local storage to build high available and scalable software-defined storage. Or if we move to the cloud, we can use Azure and Azure VMs to give us the same kind of functionality. On top of them, we can build storage pools with virtual disk and volumes and file shares. So everything would look seamless for any Windows client that we want to use. Now let's talk about different deployment options. So in a classic scenario, when we are still using RDS from the Windows Server 2012 R2, in order for you to get a working system without any high availability support, you'd need at least 6 different role services that will require you at least 8 different virtual machines. We would have machines for Active Directory, which would have been replicated. We would need at least 2 machines for SQL Server. We'll need a gateway. We would need a web interface. We would need a license server. We will need a connection broker, and then we'll need a lot of session host machines. So beside the machines that were necessary to host the client, we'll need at least 8 virtual machines around that to make these things working. Now, when we moved and we started to use RDS on the Windows Server 2016, we can actually eliminate some of the virtual machines. We need now only 5 different roles, and we can use Azure SQL Database instead of using 2 virtual machines to do that, which more or less will actually cut the cost in 2. We can take it even further, and we can use the Azure Active Directory, so we don't really need to install virtual machines. We'll let Microsoft manage all the infrastructure, and we just need the domain services. And we could even actually create a resource group together for the other virtual machines, and we will end up having two virtual machines running all the roles that we might have necessary for our application into a VM set, making everything scalable and working seamless for our application. For small deployments, we can use Azure Active Directory Application Proxy to combine all those roles together, including the license server, into one single virtual machine. So now it's time for a demo. Let's see exactly how can we deploy such an environment and how long it will take.
To help you in deploying a virtual lab on Microsoft Azure, we have built a GitHub repo that is available here in GitHub Intelequia/Virtual Labs. And here you can find a lot of information on how to start deploying this, including the Virtual Labs cost simulator that will be shown in the second session, and also more information related to the architecture of the VMs that we are going to deploy. as well as other tasks, related tasks like the how to install and set up the remote FX on the N series, and also set up the auto scaling that will be also part of the second session. So for starting, so in the first demo we saw basic deployment. So basic deployment is just if we see that here in the architecture diagrams, we can see that it's based on this type of deployment with a front end and back end VMs with one single domain controller and just one session host. So this is what we saw in the first demo. Well, in the first demo, we also added here a session host for the personal desktop and also a session host for session desktops. But in this case, we are going to deploy something more complicated, okay, more complex. But we'll see that is quite simple. So we'll be deploying the same thing, but in high availability. So we'll be deploying that in high availability by using the front end scale set with a virtual machine scale set with a different 2 VMs in the front end. The same thing for the domain controllers and also for the backend as well as for session host. So in fact, we'll be also deploying an SQL database for the connection broker. So everything will be deployed in high availability. So in order to do that, we go back here in the home page, scroll down to here to basically to the high availability deployment, and just click here on the deploy to Azure. So this will redirect you to the Azure portal. We'll ask you for credentials. So I have already logged in. So because of that, it's not asking me for that. So now it's asking me for different parameters. So just start by the resource group. For example, RDS deployment 2, for example. And in which location I want to deploy all these resources. So this is the data center location. So we can choose whatever of the available data centers, but keep in mind that not all, for example, the NVIDIA resources are not in all data centers. So you should check in the Azure portal, in the azure.com, where those resources are available, specifically the VM sizes. Okay, so let's choose then West Europe, that NVIDIA N series are there. And now start with different parameters. So asking me for administrator username. So this will be just the username for the global administrator of this thing, and also the password. Now this is going to ask me for the domain name. This is the local domain name for the internal domain. Okay, so this is going to deploy 2 VMs with a domain controller. So let me choose, for example, David RDS dash .local, and then a public prefix for the public domain. Okay, so this is going to be something like, for example, S2, and that will be the label for the prefix. So of course we could then add a custom name to that domain with just by adding a CNAME to our in our domain. So next, so asking for normally, so we are in this template. The VM sizes for front end and back end are not different. So we have just for the start as a starting point. Where just we can choose between these different VM sizes. We can let us by default, and then we have also created here like 2 type of collections. So the resource template will be able to add 2 collections. So one for GPU based workloads, and another one for CPU-based workloads. Okay, so in fact we can, for example, if I don't want to use GPU, I just also choose 0. So I will not deploy any of these VMs, but I will just deploy these 2 and these other ones. So let me set, for example, if I choose, for example, 2 and 2, this will be deploying 2 VMs of NVIDIA and in a high availability mode, as well as this same thing in, for example, if I put here 4, this will be including these 4 VMs inside the same scale set. So we'll be ready for a high availability, also for auto scaling up and down. So, well, I'm just going to, for the purpose of the demo, I'm just going to put 1 and 1. And just by clicking here and agree terms and condition and click on purchase. So notice that this is just you're purchasing directly to Microsoft, and pricing that is the official price that is on the Azure.com portal. So instead of deploying a new deployment, I have already done that. So let me close this and discard. So because that takes around 2 hours. So for the purpose of the demo, I have already done that before. And when finishing, you will have a resource group like this one. So we'll notice that there are a lot of resources, like network security groups, the virtual machines, and the network interface cards, as well as the availability sets, and more things like also the SQL database for the remote desktop broker, for the connection broker. Sorry. To make that easier to see and to explain, what I did was to put all the VMs here one by one. So here we have the domain controllers in high availability, the RDDC VM01, the same for 02, and then we have here the front end VMs that are the VMs that are hosting the web portal, as are also acting as gateways, and here we have then the backend that has the connection broker and the licensing roles, and also are consuming the SQL database for is where they are storing the user database. And finally, we have here the 2 collections that at this point has not been initialized. So we could initialize that as each one for as remote apps collection or session desktop collection. But we have created one for CPU-based load, and also another one for GPU-based workloads. So curiously, if we go here to the GPU, so we can see that as in any other we can see, of course, that is NVIDIA, okay, with the Tesla chips. And one interesting thing is that we cannot connect directly, okay, to these VMs. So in fact, to any of these ones, like also to the session host, neither, for example, or neither the backend directly. So for all, and that's the reason, is because the resource group template has secured everything inside the virtual network, and also and only here in the port of RDP is only open on the front end. Okay, so that is the inbound rule is open only to this layer. So that means that at the starting point, I only go here to the front end VMs, to any of them, and just go here, and here the connect button will be enabled for connecting. So let's do that. Let me connect to the front end VM and click open. And let's see. Okay. So this will be showing something like this when in the server manager, when this will be automatically set up everything. So and this will be the default configuration. So as you can see, all the servers will be joined to the same and the roles are already installed and assigned. So we can see that we have the VMs backend as with a connection broker, well, in fact one with a licensing role as well, and then the front end are with a gateway role and also the web access role. And finally, we have the 2 VMs with the CPU and GPU as session host to create the collections. So other thing is that we can see that here there is the high availability setup, so it's also configured. And check here the high availability setup. So for the connection broker, we can see that the connection string is pointing to the database, the SQL database that we have already created during the deployment. Okay, so other thing, we can see that we have here in the collections, we have remote app collection, we have virtual host. So in this case, so I have already set up something. So for example, I have gone here and just published the calculator, so that has convert the CPU based workload into for remote app. And the second one will be the for session host, that as soon as I haven't published any remote app yet, so will be available for remote desktop sessions. So I can continue adding here more apps. Just to publish a new remote app here, just to go and say and publish here through this wizard and set up, for example, let's see if it is the paint, okay, the famous paint. Okay, click on next and publish. So that will be, so in a second will be available just not only the Windows calculator but also paint for okay. So other thing that is not yet complete, so there is one step more manual step at this moment, is to set up the NVIDIA. So let's take a look. So we talked that we cannot directly access the NVIDIA, the GPU, and any of the other VMs directly. So what we can do is just directly from the front-end server go and open another terminal directly to that VM. So introduce my credentials. I will log in to that VM. Okay, so I am already logged in, so I can see that effectively this is the NVIDIA with the MV6 that is with 56 gigs of RAM and with 6 virtual CPUs. But one thing, so if we go here and click on properties and click on advanced system settings and click on hardware and device manager, we'll notice that the NVIDIA is not set up yet. So we need to install the NVIDIA driver. So to set up the driver, we just need to install the latest NVIDIA driver. So we in order to do that, or we just visit the NVIDIA homepage, or we go here to a chapter in the documentation that is setting up remote FX on N series. Of course, the documentation is also available in the Azure portal, and also that you can also check the NVIDIA website for the latest driver. So I'm going to click on here and download, and just download the driver. This takes some seconds. And finally, you need to restart and the VM to take all the effects. Once that we have restarted the virtual machine, we can go and check that the driver has been correctly installed just by going again to the hardware and device manager, and we can see here that in display data now the NVIDIA Tesla adapter is now available. So you can also just by using and executing here and checking the NVIDIA tool. We can check that here is the Tesla M60 is available. The temperature of the card currently, and well, currently we are seeing that this not being used. It's just a 0% because the current load is not using the card at all. One final thing to set up is the remote FX. So to set up remote FX, we need to go and open the group policy editor and go to this location. Let's go administrative templates, Windows components, remote desktop services, remote desktop session host, and finally remote desktop session environment. So here by default all these are not set up, are all not configured, and we'll need to go and enable one by one. So at least here I'm showing the recommended one, the ones that we recommend. But you can set up, for example, and go and limit the maximum color depth to whatever your needs are. to limit that will limit also the bandwidth consumed, outgoing bandwidth. But also, of course, for example, limit the number of monitors. But this one is, for example, using the advanced remote FX graphics for remote app are the ones that are using the card and that we have now set up with the NVIDIA open for a while. So finally, if I go to the portal, do you remember that we choose a name for the front-end VMs? So this is the portal, the remote desktop portal will be available in that location. So remember that you have that also available here in the front end, and here you will have the name of that location. So we just introduce our credentials, and if everything went okay, we'll see that the calculator that we had already published, but also now we have the paint. So these are the remote app collection, and here we have now the other one that is the session collection, that is session desktop, that is being baked by the GPU ones. If I go now and click on the calculator, we have the same flavor that we saw before. So we have now the calculator open here that's being executed on Azure and redirected to my desktop. And we could also have for example, paint, just having the same flavor. So here this is working as expected. So finally, if we go click on the session desktop, we can also open the session, and of course we'll have the session desktop as also expected, that where we can install, well, the administrator can install here the applications and give permissions, etc. And here it is.
So, as you can see, everything is actually quite simple and straightforward. And if you want to take a look and use it yourself, you can go into this GitHub repository, github.com/Intelequia/virtual-labs, and give it a go. We have there the documentation, we have there the ARM template, we have there the architecture diagram, so you can have a look at exactly how it is done. And with that being said, I would like to thank you for attending this first session. In the second session, as I said before, we are going to talk about how we can use the cost estimation tool in order to see how we can drive down the cost of our deployment. Thank you.